Hi there, and welcome to Seimpi Education. In this video, we will go through how to make sense of problems involving ratios. Firstly, before we jump into anything, let us identify what type of problem is at hand. There are three types of ratio problems that we are discussing today. One part constant, total is constant, and difference is constant. So let us look at one example. Jack and Jill have pocket money in the ratio 3:4. After Jack spends $7, the ratio of their pocket money becomes 2:3. How much money does Jack have at the start? As you can see, only Jack has spent money, and thus only his money has changed. We can conclude that this problem is the type one part constant. Going back to the question, it is easy for us to visualize the problem if we draw a table like so. Filling in the respective values, we realize that since only Jack's money has changed, Jill's money has remained the same. Thus, we can multiply Jill's values by the appropriate amounts to make it into the lowest common multiple, after which we get Jack's values too. Comparing Jack's before and after values, we can see that it was originally 9 units, that decreased to 8 units. So the difference, which is 1 unit, must correspond to the $7 that he spent. Using this information, we can find out how much money he has at the start, which is $56. Here's another question. Amy and Barnett have pencils in the ratio 4:5. After Barnett gives Amy 4 of his pencils, both of them end up with the same number of pencils. How many pencils do both of them have in total? So, what type of question is this? The key phrase here is that Barnett gave Amy 4 of his pencils. This means Barnett lost some of his pencils, but Amy gained some pencils, so it cannot be the first type. Since they are only exchanging pencils amongst themselves, the total number of pencils remains the same. Thus, this question is the type total is constant. Using a similar method as we did previously, we again draw a table representing the before and after ratios of both of them, with another column representing the total. Since we know the total is the one that remained constant, we can make the total values into their lowest common multiple in order to properly compare their ratios. As you can see, this is how many pencils they had at the start, and this is how many pencils they had at the end. The difference of 1 unit corresponds to how many pencils Barnett gave away, which is 4. Using this information, we can calculate the total number of pencils between them, which is 72. What if the thing that stays the same between the two parties is the difference in values? Here is another version of a ratio question. Maurice and Naomi's ages are in the ratio 2:3, and they are 4 years apart in age. Some years ago, the ratio of their ages was 3:5. What is Naomi's age now? So, the important phrase here is that they are 4 years apart in age, which means that no matter how much time passes, they will always stay 4 years apart in age. Similar to the previous question, we can draw a table but with the third column recording the difference instead of the total. Following the same method, we then convert the difference into their lowest common multiples, and then we solve accordingly. To summarize, whenever we encounter problems involving ratios, we should 1. Identify what type of ratio question it is so that we know what approach to take. 2. Use tables and models to aid in our visualization of the question. 3. Substitute our answers back into the respective ratios to make sure that the answer we got is consistent with the ratios given in the question.